Welcome to Spring LIB.
So this special relativity problem gives you a particle of mass m moving at a velocity 2.22 times the speed of light, and it asks you to find the velocity at which, or the final velocity at which, your final momentum will be twice your initial momentum, okay? So final momentum here is P sub f. Initial momentum is P naught, and final velocity is Vf. This V naught is your initial velocity, okay? And so from equation 26-4 in the book, we're given the momentum for the equation for momentum of a relativistically moving particle, and that's simply given by gamma times m times v. Gamma times mass times velocity, and so gamma actually is 1 minus v squared over c squared. Okay, and so that's your setup. What you want to do now is find v sub f such that this condition applies, right? So you have your p naught, which you can get from your v naught here, and your gamma will factor that v naught too. And so you want twice of that to be equal to your final momentum. Okay? And once you solve this, it will give you final velocity. So let's go ahead and set that up. What you have is that p sub f, or final momentum, is twice p naught, or initial momentum. This is to say, applied sign, that 2 times your initial momentum, which is mass times v naught over square root 1 minus v naught squared over c squared, so that's a ratio, will be equal to your final momentum, which is m, again, the same mass, obviously, times Vf, the final velocity, over square root of 1 minus Vf squared over c squared. That's your setup. That's the equation you want to solve. So the first thing you do is you square both sides. Okay? So that helps you get rid of the pesky squared term there. And so what you have is m squared v naught squared over, now no longer in square root, v naught 1 minus v naught squared over c squared. That is equal to m squared, notice that it's the same m, vf squared over 1 minus vf squared over c squared. Your m squareds are canceled, same stuff there, and you should note here that v naught is 0.22c, which means that v naught over c is 0.22. So all you need to do here is take the square of 0.22, and you have that, and you have v naught. So what you need to do here is find vf. Right. So it really is an algebra problem at the end of the day, because if you can solve this algebra, you very easily get out a v sub f. And let me go ahead and do that for you right now. You have, okay, so what you get from above is that 4 times 0.22 c. Remember to square the whole thing, right, over over 1 minus 0.22. It's just this part that you're squaring, right? That will equal Vf squared over your 1 minus Vf squared over c squared. Okay? And once you work out that algebra, what you find is that Vf squared is 0.203. So rearranging some terms here, times c squared times 1 minus Vf squared over c squared. And if you rearrange terms in the correct way, you get that Vf squared is equal to 0.203 over 1.203, all of that times c squared. Your final answer ends up being velocity is 0.41 times the speed of light. That's the velocity you want for your momentum to be double the initial value. And that's it.